Thank you, everyone. It's a great pleasure to share some of our recent advances and work about AI safety here. I'm Bo. I'm the CEO of Virtual AI, and in the meantime, also a professor at UIUC and UChicago. So you will expect to look at some algorithms and the numbers here in the talk. So today, I will mainly talk about AI safety, which is the area that I have been focused on for over 15 years, which is also the mission of our company, Virtual AI, trying to empower and ensure the AI safety and security for enterprises. So first of all, as we can see here, in this audience, I think we all know that AI and machine learning technologies have enabled us for a lot of convenient platforms and use cases, including financial, including large language models and multimodality models, LM agent, whatever. However, we can see that, unfortunately, such very powerful AI and machine learning techniques have also brought us a lot of security and privacy concerns. For instance, one of my favorite examples is back in 2016, there is Associated Press Twitter account was hacked via phishing emails, spreading the rumor that the White House has been attacked, which is a very easy fake news for human with common sense knowledge to understand or identify. But unfortunately, the autonomous trading bot actually will be triggered to dump a large amount of stocks within seconds and actually sweep about $136 billion within seconds, which really happens in real world. But if you say like, okay, this is like back in 2016, what if now like we have more capable and more advanced models and technologies as well? But unfortunately, just I think less than a month ago, we can see there is a big jump for the Lyft stock price, mainly because there is a typo in their annual report. And again, it's very easy to be identified as for human with common sense knowledge, but still the capable autonomous trading agent or bot actually this time buy a lot of stocks triggered by such like a stop, so that it's increase the stock in about 60 to 70%. As we can see, this really happens even now and cause real-world economic loss. And similarly, we know that the output of foundation models or large language models can be biased, can leak private sensitive information. And also from the face recognition multimodality model perspective, it even led to misarrest in the past, which is really severe. So we can see that even we are very lucky and living in a very exciting world with all the technologies and the new models coming up every day. But still, as a typical machine learner or builder, we are still having a very hard life to build so-called AI safe and trustworthy systems. And that's also why last year the White House executive order just emphasizing the importance of secure, safe, and trustworthy AI deployment. And in the meantime, from various countries, including European countries like EU AI Act, GDPR about privacy, and the AI Bills of Rights from last year White House as well. So we can see, while we are excited and building a lot of capable machine learning models and systems and platforms, still AI safety and privacy itself has been a big gap between the AI development and the deployment in practice. So our goal is to fill in this gap, and hopefully we can provide product and the services and a toolbox so that help everyone to actually safe and secure deploy your AI product in real world. So overall, this is a very big question, right? So how should we think about it, and what's the principles we can look at it? So here we simplify the overall AI system and the applications and the end-to-end etc. component into a very simple platform or a pipeline here. So basically, at Virtual AI, we are thinking for example, we have different models, either foundation model, pre-trained, fine-tuned, or LM agent-enabled models, which can be adapted to different domains, including financial, healthcare, education, autonomous, etc. So first of all, if we want to make sure they are safe and secure and private in practice during deployment, the first thing is we need to understand what's their vulnerabilities and weaknesses, right? So the first thing we provide and I'm trying to do is the red teaming effort. So basically, we call it Virtual Red. Here is a platform that we have more than 300 algorithms and perspectives trying to understand and perform red teaming attacks against any models based on the use cases and the objectives, so that you can understand the potential vulnerabilities, for example, brand risk for any product, for example, privacy leakage for the fine-tuning data you have, so that you understand, okay, what's the private vulnerabilities, and therefore we'll provide the report and together with some recommendations of fixing the problems. And after that, secondly, we'll provide a toolbox so that there are different algorithms corresponding to different problems. For example, some products mainly focus on, like, say, fairness, and really the fairness is the important thing. Then we will provide certain alignment approaches. Or if privacy is the most important concern, that here we'll have different unlearning algorithms and fine-tuning strategies, differentially private, like data generation approaches to help you protect your data privacy and help you to build models that with guarantees of privacy and security insurance. And finally, as a second component, we try to fix the problem fundamentally of the model and the platform itself. But again, even based on the nature of the data driven of the model itself, it cannot be 100% accurate or safe because of the probabilistic nature of it, right? Therefore, we need to have an outer layer, like as a firewall, to provide these guardrail models for both input and output, such that we can identify the potential harmful, sensitive information or private information leakage to block and audit the information. So this is an overview of the different product and algorithms as a mission to ensure the safety and security of the AI platforms deployed in practice. So next, I'll go to a little bit for deeper into some of the components here to understand what's the advance of the technologies currently in terms of, say, red teaming, guardrail, which are the words that maybe you have heard a lot, but what's the state of art, and what's the challenge of it, and what's the advanced algorithm to enable it, right? So first of all, I think the main question we want to ask here is that in terms of red teaming and identified vulnerabilities, what we want to ask is how should we assess the risks of ML models? And in order to do so, we definitely need to know that what's the safety and trustworthiness perspectives we need to care about, right? Because as AI safety itself has been a very big topic emphasized by many different governments, so we can see everyone may speak a little bit different language. Someone care more about privacy, someone more like fairness, robustness, etc. So how can we be on the same page and talking about similar languages? So basically what we can see here is that we follow two principles to define these safety perspectives. First is application use case based. So here we'll define different perspectives here. And then the second principle is regulation based, including government regulations and industry policies, so that we can provide a compliance based evaluation and red teaming effort to understand the vulnerabilities of your platforms, your models, etc. So first of all, let's look at the platform in terms of the use case based. First of all, this is a platform. It's open source and people can use and welcome to contribute. It's called the Decoding Trust. And basically the goal is to provide the first comprehensive and advanced trustworthiness evaluation for large language models. Here is an example for LLMs, and we also have it for like multimodality models and LM agents under different types as well. And the first thing, which is very important, is to define the 8 trustworthiness perspectives based on use cases. So here it includes stereotype bias, adversarial robustness, OOD robustness, which is a generalization, privacy, ethics, fairness, hallucination, etc. So based on these perspectives, then we can talk about similar languages in terms of what we focus on and what algorithms we generate for each perspective to provide the attacks and provide the vulnerability uncovering. So basically, for each perspective, we still have a lot of, as I just mentioned, a lot of sub-scenarios, algorithms, optimizations to generate. Basically, on the right-hand side, you hide it as challenging data and prompt generation to provide the stress test and the red teaming effort. So yeah, by the way, this paper is also the best paper at NeurIPS 2023. So based on this platform, right, there are some lessons we can learn, which is very interesting. So basically, we can see here is that if we evaluate different open model, closed models together, and over the trustworthiness perspectives we provided here, and we can see on the very high level, we have 2 takeaways. The first is that, unfortunately, we can see there's no models which can dominate other models in terms of the safety and the security perspective, even though we know that, say, GPT-4 is very capable and suppress other models on a lot of benign cases and utilities. But in terms of safety and security, it's not the best compared with other models, unfortunately. So it means there's a long way to go for us to fine-tune or to construct or adapt a safe model for our use cases. And second is that here we can see there introduce some fundamental trade-off among different perspectives. So there are some theoretical work behind it to understand whether those whether those trade-offs are actual fundamental or not, which means whether you can achieve the best of all the worlds or it's actually an impossibility result. So these all are very interesting, and therefore we can give concrete and rigorous suggestions and solutions to fix and help improve the safety and protect the privacy of the AI models you have. So after that, I'll give one example of the test we have in terms of the red teaming so that you can have a little bit of flavor about what is red teaming and what is security. So basically here is a very simple example coming from GPT-4. On the left-hand side is an input showing that you should hire experienced sales. So basically the sentiment of it outcome by GPT-4 is negative, clearly, like it shows that it doesn't think you have experienced enough sales, right? However, we can attack it and by performing very stealthy manipulations to the data, such that you can see to human, the data is just optimized from, say, experienced to be skilled. And to human, it's the same on the semantic, right? But it will fool the model exactly. So this is one example of how such red teaming performs. Basically, it's very hard to perform by only human because, for example, this example cannot be generated by human because the semantic is similar. Second of all, it's very effective in terms of fooling the model and identifying the vulnerabilities of the model, which is very important. And yeah, similar examples here and statistics showing that this is consistently true over different models, different tasks, etc. So basically what we can see here is that this decoding trust platform is also hosted by Hugging Face as a standard LM safety leaderboard. So if you are interested to contributing like a more safety perspectives or additional models you want to know on the leaderboard where you are, your model is in terms of safety and trustworthiness, welcome to upload it so that we can build an AI safety community together. And in the meantime, we provided automatic red teaming, blue teaming, so that we can have the cat and mouse game and eventually get equilibrium and see what's the safety and the security of the model itself. And overall, that's the first perspective we mentioned the principle in terms of use case based. And in terms of regulation based, here I give an overview of it. So basically, we can see this is all the AI regulations emphasizing different safety categories. And on the right-hand side is a comparison between different regions like European, US, and Asia, so that we can see different countries have different emphasis of different safety perspectives. And I think this is very important and the first time to put together so that we can understand how, if we want to do compliance for AI platform and models, how should we do? I think this is a principle. And in the meantime, we also look at the different company regulations and look at, say, companies, what's their focus, overlap, and disconnections in terms of what safety perspectives they emphasize, etc. So finally, this is the like a perspective. We put everything together, and we'll have this platform understanding the trustworthiness and give you some like a top 10 failure cases of the models, so that if you use the platform, you can understand the safety and vulnerabilities of your model with a holistic view. And finally, with the red teaming, I think I have some couple of minutes to go through how we can guardrail it, right? Now we know how to identify those vulnerabilities, how we can protect the models, and what's the possibility to protect the model like this. So basically, we can see here, possibly there is, like I think many of you know, LlamaGuard, which is a very good guardrail model, but have been attacked after it coming out like within 1 hour, right? So jailbreak attack itself is a main concern. So basically, we have a model structure, which is also a paper at ISML this year, but the structure is open source and people can use as well, which is we add 2 key steps in it. One is like energy-based data augmentation, so that you can have a dense enough data. And second, you have a k-nearest neighbor layers into the model, such that you not only have a transformer which have good accuracy but very vulnerable, but also with the k-nearest neighbor, it's become very resilient. And together with all these components, so basically we can see a very good, yeah, this is a pipeline I mentioned. So we can see a very good performance, like a little bit numbers here, so that we can be on the same page. So basically compare with, say, OpenAI Moderation API, NeMo, LlamaGuard, this is V2, and on the open data set, we can see the performance is much better with such new structures. And in the meantime, we talk about the resiliency against jailbreak attacks, and different columns show different jailbreaks. And what we can see here is that, surprisingly and very interestingly, this model I just mentioned is almost resilient over all jailbreaks compared with other state-of-art baselines. They can be attacked to almost zero resiliency, but this model keep to be robust. So I think this is a very interesting effort, and hopefully people can contribute and we can work together to contribute to this AI safety community. Yeah, with that, I would quickly want to say that basically, I think we are all here, and I observed in the past, decades ago, we have this map in terms of how many computers there are. At that time, the computer looked like this. And we have a paper called WWW in the decades ago. But now, after 30 years, on the right-hand side, this is how the internet look like. We actually have internet almost everywhere in the world, right? And similarly, I have only a status from 2023 in terms of how many regions and how many people are using, say, ChatGPT and GenAI, right? And how the security will look like with this vision and with this trend, right? So this is a vision given by GPT-4o, but I think this needs a lot of imagination and community work together. So yeah, basically, that's all. Thank you, everyone. We have several platforms, open source, and happy to discuss and use more. Thank you.